Hi, my name is Andrew. This is my video assignment. I've selected for this function the square root function. So we have y equals square root of x and a base function to demonstrate the process for transforming a base graph. If I was given a function defined by g bracket x equals af k bracket k and then x minus d plus c. This describes the transformation of the graph of f. So if that f becomes x equals square root of x, then the g equals x equals to a square root of that k with the x minus d with that plus c on the outside. So just with that square root function, that's how you transform it. The a value describes the vertical stretch of that compression. For example, if a equals 2, then there's a vertical stretch by the factor of 2. If a equals 1/2, then there's a vertical compression by a factor of 1/2. If the a is negative, then there is a reflection along the x-axis. The k value in this situation describes the horizontal stretch of comparison. For example, if that k is equal to 2, then there's a horizontal compression by a factor of 2. If k equals 1/2, then there's a horizontal stretch by a factor of 2. If the k is negative, then that's a reflection, but along the y-axis. The d value here in that x minus d describes the horizontal translation, so left or right, and the c value describes the vertical translation, so up or down. It's also important to note that the order of applying the transformations, so you don't want to go in like just a random step. You want to do first all the stretches and comparisons, and then you want to do the reflections, and then you want to do the translations. So translations last, stretches, comparisons first, and reflections second. It's also possible to apply mapping notations when you're doing transferring the points to the original function using x bracket, here I'll write it, bracket x y then transforms into x over k plus d a y plus c. So that one at the bottom there, it's possible mapping notation. That is a y. So given the base function is a square root function, we can use its key points, and apply the transformations to the each of the points found in the image points. So the key points I would use would be 0, 0, 1, 1, 4 and 2, 9 and 3, and it would be 18 and 4. So let's use an example to demonstrate this pretty quickly. Let's use f at x equal to -3 power of 1/2 x minus 1 plus 2. Okay. For this function, we have a reflection in the x-axis. You can see that because there's the negative. Vertical stretch by a factor of 3, which is that 3 right there, I think. Yeah, right there. It's that 3. We also have our horizontal stretch by a factor of 2, which is that 2 at the end. That 2 at the end there, it's the vertical part. So then the a equals the 3, the k equals 1/2, and the d would equal 1 here, and the c would equal 2. You can take the key points and use mapping rotation to find new points, such that x and y maps onto 2x plus 1, so that works with that. 2x plus 1, and then -3y plus 2. So 0, maps onto 1/2, 1, maps onto 3 minus 1, 4, 2 maps onto 9 minus 4, 9, 3 maps onto 19 minus 7, and 16 minus and 4 maps onto 33 and minus 10. The domain for the base function is x is equal that r, and the range for the base function is y is equal to r slash y greater than 0. So the transformations that affect the domain are relations in the y-axis and horizontal translations. So the transformations that affect the range are reflections in the x-axis and vertical translations. So in this case, since there's a horizontal translation right 1 unit, the domain becomes x equal to r slash x greater than 1. And since there's reflection in the x-axis and a vertical translation up 2 units, the range becomes y is equal to r slash y is less than 2. Sorry. We'll also demonstrate how to apply each transformation one at a time on graph paper. First, by vertically stretching the base function by a factor of 3, then horizontally stretching it by a factor of 2, then reflecting it along the x-axis, and then horizontally translating 1 unit to the right and vertically translating 2 units up. I will attach that graph paper after, and thank you very much.